Welcome to Byte Size Data Science. We now have a deployed model. How do we know it really gives us what we want? How can we trust it? This is the subject of this video with our guest speaker, Eric Martens.
Hello, and thanks for having me on your channel, Jacques. It's incredible to see you closing in on 500 subscribers. I'd like to talk today about trust. When it comes to data science and machine learning, you can learn all the cutting-edge algorithms and techniques, but if you want to use your skills to solve real-world problems, you'll need to convince people that the decisions and predictions your models are making are trustworthy, grounded in logical principles, and robust enough to deal with changing conditions. There are three main boxes you need to check in order to have a trusted machine learning solution. The first, which I'll cover today, is explainability. In future videos, I'll discuss the other two, addressing unfair bias and handling model drift. We can claim our models are explainable if we can identify how important the feature values are to the final prediction. For some algorithms, such as random forest classifiers, it's pretty straightforward to generate a feature importance graph that shows the overall impact of the features on the model. However, if you're using black box algorithms like neural networks, or if you want to take a look at individual predictions, those graphs don't provide enough information. For example, we'll take a look at a machine learning algorithm that's looking at credit applications and using data like past credit history, checking account status, and more to determine if the application is risky or not. This kind of automated review is a common use case because it can ease the burden on human loan officers by screening out and denying obviously risky applications. At the same time, government regulations may require us to provide detailed explanations of our model's decisions. So how can we generate an in-depth explanation of an individual prediction? One industry standard uses the LIME algorithm. LIME stands for Local Interpretable Model Agnostic Explanations. As the name suggests, it can work on a huge range of models, from decision trees and random forest classifiers to gradient boosting classifiers and neural networks. LIME works by perturbing the request, making small changes to the feature values, and sending this new data to the model and seeing how the changes affect the prediction and the associated probability. In our example, let's say I'm a 41-year-old male applying for $10,000 in credit with $5,000 in the bank and $2,000 in outstanding credit. LIME will perturb the data and send the changes to the model. What's the output if I'm 35 years old? What if I'm asking for $12,000? What if I have no outstanding credit? What if I owe $4,000? By performing thousands or tens of thousands of these perturbations and aggregating the effects, LIME can tell us exactly what caused our model to make the prediction it did. Let's take a quick look at the output of the LIME algorithm from Watson OpenScale, IBM's tool for monitoring and explaining AI models. Here, we've got a nice visual representation of our feature importance. In this case, our model decided the credit application is not risky, and it's 73% confident in that decision. On the right side of the screen, we can see that the relatively small loan amount, the short duration of the loan, and the age of the applicant were the three most important factors that influenced the prediction. On the left, we can see that the length of the time this person has spent at their current job, as well as how long they've lived in their current residence, were factors that influenced the model towards a risky prediction. They weren't enough to outweigh the other features, but they did lower the model's overall confidence. So we can provide our detailed explanation and make our customers or regulators happy, but how does this translate to trust? By generating these explanations, we can make sure our model isn't basing its decisions on obscure, nonsensical information. For instance, if we kept seeing the age or gender of the applicant as the primary motivating factor in our predictions, that's a good clue that we need to take a look at our training data distributions and model outcomes. In this video, we discussed why it's important to show that we can trust our models to make reasonable predictions, and covered one way in which we can start to gain that trust. If you're interested, there are links in the description below to more information on LIME, as well as the open source AI Explainability 360 toolkit with code samples and demos to get you started.
Now we know more about trust and the LIME algorithm. More on trusting your deployed models next time on Byte Size Data Science. And don't forget to subscribe.